So what you're looking at right now is our very last notes video. And we're going to be using this notes video to kind of do a big review on all of the different topics that we've covered this year. So this is kind of going to be like a brain dump or like a little study sheet for our Math 7 concepts. So first thing that you're going to want to do is put your name up at the top left-hand corner so that you know that this is your study sheet. And then we're going to do kind of a little key. So we're going to put a little star here, and whenever we put a star in one of these study boxes, that's a clue that that section is no calculator on the SOL. Remember, on the 7th grade math SOL, there's the very first section of about 8 or 10 questions is no calculator allowed, and so there are some things that you need to remember how to do. So we'll go over those as we come across them. So first off, let's talk about powers of 10. Remember, you want to use on your calculator the y to the x button. That's going to help you out with exponents. 10 to the 5th power is a 1 with 5 zeros. 10 to the 0 power is just 1. And the negative powers, put it into the bottom of the fraction. So 1 over 10 to the 5th power. And then we can also go through and solve that. 5, and that would be 0.00001. Now, scientific notation is one of those no calculator sections. So we're going to put that little star there to help us remember. Remember, that box can only hold one number, and all the other numbers have to go on that blank after the decimal. The exponent tells you how many hops to take. Remember, if that is a positive exponent, you're going to move to the right for a very big number. And if it's a negative exponent, you are moving to the left for a small number. So remember, something like 0.000. And remember, sometimes we have those questions where they ask you to put it in order. So to put things in order, first you want to look at the exponent. And that's pretty much going to cover all of our hints and tricks for scientific notation. Sliding our sheet over, and remember, you do need to pause the video if I'm moving a little bit too quickly for you, is our sequences box. Now, we have two different kinds of sequences. First, we can have our arithmetic sequences. And remember, arithmetic sequences are when we are adding. There is no such thing as subtracting, and that's why I crossed it off. Remember, you can always add the opposite instead of subtracting. And we also talk about common differences with these. And I am going to shorten some things, so if you'd like to write out the entire word, that's all right. So when we multiply or multiply by a fraction instead of dividing, we call those geometric sequences. And those have common ratios. So that number that you're multiplying by each time, that's the common ratio. Now with integers, this is another no calculator section. So we had a couple of rules to help us. Our adding rules, a positive plus a positive is going to equal a positive. We've known that since elementary school. And kind of going right along with that, a negative plus a negative is going to equal a negative. If I have red chips and I add more red chips, I'm still just going to have red chips. Now where it gets a little bit tricky is when you have one of each, so a positive number and a negative number. Then we're going to have two steps. Our first step is to take the sign from the bigger number. And remember, when I say bigger number, I mean the absolute value. And then we're going to subtract. Now, when we subtract, I hate subtracting. Remember, I drew sad faces everywhere when I had to subtract. I want to change that into an addition problem. So I can do same plus the opposite. You can also write down the KISS method, keep it, switch, switch. Either of those will help you out with subtracting. Multiplying and dividing was my easiest rule. We talked about Mad Bob. Remember, Mad Bob can only be used for multiplying and dividing. He looks like an upside down triangle. Subtraction signs for eyes, plus sign for a mouth. And that's Mad Bob for you. Moving down to our next row. I'm actually going to go all the way over to the left. We have FDP. FDP is another no calculator section. And that stands for fractions, decimals, and percents. Remember, whenever we put them in order, we want to change them to decimals. Because those are really easy to put in order. Since we don't have a calculator, if you don't remember what a fraction is as a decimal off the top of your head, you can do long division. So you put the top number inside the box, the denominator outside the box. And if 5 doesn't go into 3, you can add a decimal and a 0 and just bring that decimal straight up. 5 goes into 36 times, which equals 30. Subtract, it's 0. So 3/5 is equal to 0.6 or 6/10. 60% when you want to change a percent into a decimal. Remember, you put the decimal at the end, 2 hops backwards, and that equals 0.60, which is also the same as 6/10 as well. Square roots, another non-calculator section. Remember, the square root just means that if I was going to make that perfect square into a box, it has to have the same number of little squares on either side. So here I have 25 little baby squares making up this larger square, and each side length is 5 squares, tall or long. 5 times 5 equals 25, and 25 is that perfect square, whereas 5 is the square root. So just knowing the difference between those. Moving right along, talking about absolute value. Absolute value is the distance of a number from 0 on the number line. So the 5 is 5 hops from the number line. Same way that -5 is 5 hops from the number line. Now, when we have it on the outside, you have to think about that like an opposite sign. So that's the opposite of 5 hops, which is -5. Same thing here. As long as we have that negative on the outside, that tells us our answer should be the opposite. Now, WKUs. We talked, going right back, sorry, absolute value is a no calculator section. So make sure you know those rules. So WKU, we have the W stands for words. The K stands for what you know. And the U stands for what is unknown. So we like to circle our numbers and underline our labels, and that helps us out. Those labels go straight into the words section. Tax, tip, and discount. The first step is to change the percent to a decimal. Then you're going to multiply by the money. And then our third step is to sometimes add or subtract with the total. The way that you know if you're adding or subtracting, well, remember tax adds, tip adds, and discount subtracts. So that's just a little hint to help you remember those pieces. And the last section on the second row, we have, it kind of looks just like 2 fraction bars. Remember, is over of equals percent over 100. Oh. Rewrite that, percent over 100, only 2 zeros. And that's our last kind of proportion that we can make up. Moving right along, and I know I am moving quickly, but we have a lot of things we've learned this year, so I want to make sure that we get through it all. Surface area and volume. Remember, surface area is when it is covering the shape, and we also have units squared, whereas volume fills up the shape. and we can have units cubed. So those are just the labels. It doesn't mean that you need to square the answer or cube the answer. It just means that surface area is a two-dimensional, volume is three-dimensional. Remember, this shape right here is our rectangular prism. I'm just going to shorten this. And this one that looks like a can of soup is a cylinder. And this is where we need to use our formula sheet. That is super important. You do not have to memorize those formulas. You will be given a formula sheet at the start of your SOL to use throughout your time. This next piece, there's not really anything to remember, but I did write down some of these little clues. So remember, the G stands for those grouping symbols in GEMDAS, like parentheses or brackets or absolute value bars. The E stands for an exponent, that small little number up top. Multiplying and dividing is in the same step from left to right, the same way that adding and subtracting, same step left to right. Moving right along to similarity. We have A, B, C, D is similar to D, E, F. Remember, the way that they write these is incredibly important. So since B is in the middle, it goes with E because angle E was in the middle. Also, AB, well, I'm looking at the first two letters here. First two here goes with DE. So even without seeing that shape, if they give me the name with the letters in a certain order, I can use that to my advantage. Next up, we see our quadrilateral family tree. Remember, quadrilaterals, if you have one set of parallel lines, that's a trapezoid. Two sets is a parallelogram. Once we have a parallelogram, we can break it down even farther. Maybe it has 4 right angles, which makes it a rectangle, or maybe it has 4 equal sides, which would make it a rhombus. And if it happened to have 4 right angles and 4 equal sides, that would make it a square. Once we draw this family tree, and this is a really good thing to just have memorized, we can use that always, sometimes, never. So if we're moving up the tree, like from parallelogram to quadrilateral, that's always true. A parallelogram is always a quadrilateral. But if we move down the family tree, such as quadrilateral to parallelogram, a quadrilateral is only sometimes a parallelogram. Sometimes it's just a quadrilateral, or maybe it's just a trapezoid. And then if you are moving side to side, that's one of those cases where it's never true. For example, trapezoid to parallelogram, those are side by side. So a trapezoid is never going to be a parallelogram because they're side by side. Moving to this last section of this row, we've got our transformations. And there's a lot to remember here. So translations, I've underlined the SL. Remember, we remember those as slides because SL is also in slide. Reflections, you can think of flips, and it's got the FL in it to help you. Dilations are when, oh, I skipped one. Rotation is when you turn. And remember that word rotate is hidden in there. Dilations make a shape bigger or smaller. And sometimes we talk about scale factors. Scale factor is just the number that you are multiplying by. I have a little arrow to help you remember which way clockwise and counterclockwise are. Remember, 90 degrees rotation is 1 turn, and 180 degrees are 2 turns. Then I've labeled my X and Y axis. Remember, the X axis goes side to side, the Y axis goes up and down. And we see, my tools are kind of blocking it, but you can see the X, Y, the X is the input and the Y is the output. Moving down even further and all the way over to the left-hand side of the box. Probability, this is a big box. This is what we've just covered. Remember, it's want what you want over the total. So how many total things you can get. We have experimental probability, which is what actually happens. Remember, you have to have real results. Maybe you have a chart. Maybe you have tally marks. Maybe they have actually rolled the dice and written down what they've gotten. Then we've got theoretical probability. Remember, theoretical is talking about in theory, or what you think will happen. Remember, a lot of times we're talking about spinners and dice when we talk about that. I'm going to move down so we can see both of these two together. Independent and dependent. If it is independent, that's when we put the marble back in the bag. And we have the same denominator. Whereas dependent is when I keep the marble out. And that's when we can have different denominators. And the last thing, if I have two different events in those parentheses, so here I have A, comma, B, you have to split those two pieces up. So the probability of A is its own fraction, and then the probability of B is its own fraction. So for example, if you have 1/2 and 1/3, you multiply straight across, that equals 1/6. And you do want to simplify if at all possible. Moving up and kind of right smack dab in the middle of our sheet, we have our fundamental counting principle. This is also part of our probability and statistics unit. Remember, fundamental counting principle is all about the multiplication. So for example, if I have 4 pizzas, 7 toppings, 3 drinks, and I'm asking how many different options are there, you want to multiply all of those numbers together. So 4 times 7 times 3 equals 84. So for that example, I have 84 different pizza combos that I can make. Looking down at histograms. Histograms kind of look like bar graphs, and I drew you a little example. There are no overlapping intervals allowed. Your bars tell you the number of times that it happened. And the total, if they ever need you to find out the total without telling you, you have to add up all the bars. I'm just going to keep moving down in this row. I know I'm kind of jumping around, but I want to touch on this translating section. Remember, when you're translating phrases, there are a couple of things that like to trip us up. Less than is one of those turnaround phrases, so you do need to move it around. So if you say x or 3 less than x, you actually have to switch that around, so it's x minus 3. With times the sum, that's our parentheses phrase. So if I have 3 times the sum of 5 and 2, we would write that as 3 outside the parentheses, and then 5 plus 2 inside the parentheses. And remember, is just an equal sign. Here we are at the functions box here. So I have an example of a function y equals 2x plus 3. Remember, the first thing you want to do when you get a function is to make yourself a table. And I like to even give myself some workspace in the middle. So here I have the x on the left, the y is on the right. I have to put that function in the middle so that I know what work I'm going to be doing. I always like to pick numbers, some that are negative, some that are positive, and I like to have 0 in there. And then each time I'm putting in a different x. So I can go through and just fill in all of this completely. And when I put in -1 and 0 and +1, I'm going to get different answers. So on my y, I've got 1, 3, and 5. And then I can use that information to go ahead and make coordinates. So remember, your x comes first and then your y. So my first point is -1. When I put -1 in, I got +1 out. When I put 0 in, I got 3, and 1, 5. So those are 3 points that go with that function. All right, and now I've got to kind of erase my ink so I can move down and show my graph. But my points here, remember, were -1, 1, 0, 3, and 1, 5. And remember, you always want to graph your x first. So for negative 1, 1, you start at the origin, move left 1, up 1, 0, 3, you keep at the origin, go up 3, and 1, 5 right here, and then you can go ahead and connect those dots.
Label which axis is x and which axis is y.
Moving on to our equations and inequalities. Remember, I always like to draw my railroad tracks here. I talk about my best friend is the number that's with the x, and my regular friend has a plus or a minus with it. The first thing I want to do is get rid of my regular friend, so if they were adding, I'm going to subtract. Then my best friend and my variable are still there. Just do the math on the other side. Remember, squish together means multiply. If you do the opposite and divide, you'll be left with just the variable. Same thing on the other side, divide by 2. So x in this equation equals 5. You want to get rid of the friend before the best friend, and we have to use the opposite operations. When we talk about inequalities, we have open and closed circles. So if we have no line on the bottom, that's going to be an open circle. If there is the line on the bottom, that's a closed circle on our number line. And we have to flip our signs if we multiply or divide by a negative number. Go ahead and fill that in if it got cut off a little bit on yours. Last thing we're going to talk about is our properties. We have a whole bunch of properties that we talked about. Our first one was commutative, where we change the order. And remember, we remember that because it has CO at the beginning. Associative is where we change our groups. And that looks like the parentheses are changing. Remember, it begins with always stays same order. So that's a good way to make sure you know the difference. Identity is where we end up with the same number. So either you are going to be adding 0 or multiplying by 1. Inverse, another word for inverse, is the opposite. So if you have a fraction like 2/3, the inverse is 3/2. If you have a negative number like -2, you can use a positive 2 as the inverse. Last couple here, we've got distributive property. We always like to talk about our mailman. Remember, you have the number on the outside of the neighborhood, and then we have the houses on the inside. So you would have to multiply that 5 by both the 2 and the 3 to pass out that multiplication. And very last property, the multiplicative property of 0. Any number times 0 is going to equal 0. So that covers everything we've talked about in Math 7. I know it was a lot, but we worked really hard this year and we are ready for that SOL.